Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm answering a question submitted by a student. You can see it here. We're trying to divide two polynomials, p of x and d of x. And unfortunately, we cannot use synthetic division. So most of the time, we would prefer to use synthetic division. But in order to use synthetic division, the denominator has to be linear. And you can see that this denominator is not linear. It's a squared term. So let's set up the problem, and then we'll get to work on it. So we have, oops. What we're trying to solve is this division, 20 x to the fourth plus 16x cubed plus 9x squared over 4x squared plus 1. Okay, so we're forced to use long division because the denominator is a quadratic, not linear. So we're going to put our 20x to the fourth plus 16x cubed plus 9x squared. And we need a placeholder for the x term. And we need a placeholder for the constant term. You can see this expression doesn't have an x term or a constant term, but we actually have to allow for those things. That's being divided by 4x squared plus 1. Okay, so we just look at the leading term here, and you can see this would be 5x squared. So I'm going to put a 5x squared here, because when I multiply 5x squared, distribute that through here, I'm going to get 20x to the fourth plus 0 plus 5x, 5x squared. That's a 4x squared plus 1 here. And you can see how you have to be so careful, get everything lined up. We're going to subtract now, so this minus this is going to give you 0. I'm just going to leave that blank. This is going to give you 16x cubed. This is going to give you 4x squared. I like to copy these out. Sometimes students don't like to be bothered with this, but I think it just helps everything. Just keep it nice and neat. Keep everything in its proper column. Okay, so here, this is just going to be 4x. Because when I distribute the 4x against this, I'm going to get 16x cubed plus 0x squared plus 4x plus 0. Once again, I just like to keep my columns straight. So 16x squared plus 4x, 16x cubed plus 4x. So this goes away. This is just 4x squared minus 4x plus 0. And we have one last term to do, which would be the x squared term. You can see 4x squared here, 4x squared here. So my constant here is 1. So I'm going to get 4x squared plus 0x plus 1. And we subtract again, that goes away. Negative 4x squared. Oh, sorry, negative 4x, just 4x here, minus 1. So now we can complete this statement. So this divided by this is just going to be 4x squared. Oops, sorry. We're going to get 5x squared plus 4x plus 1. And our remainder is negative 4x minus 1 all over 4x squared plus 1. So that's the way it looks. And this is normally the way they want, teachers want you to express this. I could make this a negative here. I just soon leave it like this. It doesn't matter. But now we're going to multiply because we want this without the denominator. You can see the dx this denominator. We multiply both sides by the denominator. So we're going to get 20x to the fourth plus 16x cubed plus 9x squared equals 5x squared plus 4x plus 1 times 4x squared plus 1, and then minus, now I'll just group these, 4x plus 1 net. So our remainder, our x, is negative 4x plus 1. And then the denominator here, this is dx here. Let me just use color. And I'll just show you how it maps up with what we're being asked to find. Oops. Get some color in there. Okay, so this is our quotient, q of x. This is our denominator, d of x. And this is our remainder, r of x. As I say, most people like to write it this way, but if you multiply both sides by the denominator, 4x squared plus 1, you're going to get this multiplied by 4x squared plus 1, and then the 4x squared plus 1 disappears from here and here. Okay, so that's it for this problem. It's fairly straightforward, but tedious. Not that difficult. You just have to make sure, be very rigid about the way you get things lined up, and make sure to leave placeholders for the powers that are missing. Okay, that's it for this. I hope this was helpful to you, and I'll see you again next time. Bye-bye.